All right, we want to start today with working in groups to do a little more practice on the definite integral. So you can choose your own group, but go ahead and pull into a group and try this one, and then we will look at it together. All right, so let's look at the definite integral that I asked you to work on in your group. So you can see our starting value is going to be 0, that's A. Our stopping value is going to be 2, that's B. So our change in x is just going to be b minus a over n, or 2 over n. So our starting value, we would start at 0 and go to 2 over n, and then the next interval we'd go from 2 over n to 4 over n, and then 4 over n to 6 over n, and so on. So x sub 0 would be 0, x sub 1 would be the 2 over n, x sub 2 would be the 4 over n, x sub 3 would be the 6 over n. So to find x sub I, remember that your formula is going to be a plus the change in x times I. So our a value was 0, our change in x was 2 over n, so that just gives us 2i over n. And you can see if you plug in 0, you do get 0. If you plug in 1, you do get 2 over n. If you plug in 2, you do get 4 over n. And if you plug in 3, you do get 6 over n. So you can see how all that fits together. But honestly, the only thing that we need is the change in x and x sub I to move forward. So we can just use our formulas for that and not have to map out all the intervals and identify all of these values. So if we have f of x sub I, remember that x sub I was 2i over n, and then the change in x was 2 over n. So f of 2i over n literally means put 2i over n in the place of x in your function, right? So that would be 2 minus 2i over n squared. So that's what you see right here, 2 minus 2i over n squared. Remember that n is just a number of rectangles, so 2 over n would be a constant, and so we can pull that out in front and get it out of our way. To simplify this a little bit, 2i over n squared would be 4i squared over n squared. So I have two pieces that are being subtracted. Let's divide that into two separate summations. So for the first one, we've got the 2 over n out in front, and it would just be the summation of 2. And then for the second one, we've got the 2 over n out in front, and it would be the summation of I squared, because the 4 over n squared could go out in front as well. So summation of I squared. Okay, so if we go back to those summation formulas, we said that the summation of a constant would just be that constant times n. And you also still have your 2 over n from out in front. And then here, 2 times 4 is going to be 8 over n times n squared is n cubed. And our summation formula for I squared you can see here. All right, so clean this up a little bit. The n's would drop out, so 2 times 2 would just give me 4. And then I want to here put my numbers together, so I'm going to put 8 over 6, and that would simplify to 4/3. And I'm going to put the n cubed over here with my n's. And so, of course, the n in the numerator could cancel with one of the n's in the denominator. So that would leave me with n squared in the denominator. So let's go ahead and FOIL this out. N times 2n is going to be 2n squared. N times 1 is 1n, and 1 times 2n is 2n. So 1n and 2n is 3n. And then 1 times 1 would give us 1. So that's the only thing that changed in that step. All right, so 2n squared divided by n squared would give us 2. 3n divided by n squared would be 3 over n. And then 1 divided by n squared is 1 over n squared. So now we're ready to take our limit. So when you take the limit of a constant, it's that constant. The limit of a constant is that constant. The limit of a constant is that constant. The limit of a number divided by a variable when you are approaching infinity is 0, and number divided by a variable when you're approaching infinity is 0. So that's going to give us 4/3 times 2 is 8/3. That's going to give us 4 minus 8/3, or 4/3, and that is the exact area under the curve. Now, we also said that sometimes these problems are too elaborate to evaluate, and so we set them up only. All right, so let's practice one more of those, just a setup only. So to begin with, let's find change in x. How do we find change in x? Well, it's b minus a over n. So you can see b is 10, a is 2, and we don't know what n is going to be, so we just leave n there. So change in x then would be 8 over n. Then we need x sub I, and remember that x sub I is going to be a plus the change in x times I. Our a value was 2 this time, so that's going to be 2 plus 8 over n times I. So 2 plus 8i over n. All right, so remember that for the formula for the definite integral, it's going to be the limit as n approaches infinity of the summation from 1 to n of f of x sub I times the change in x. All right, so we can put our x sub I right here. That was 2 plus 8i over n, and we can put our change in x right here. That was 8 over n. Now, 8 over n is just a constant, so we can move that out in front and get that out of our way. And so now we need to plug 2 plus 8i over n into f of x. So f of x was x to the 6th. So if I put this in the place of x, I'm going to have 2 plus 8i over n to the 6th. So 2 plus 8i over n to the 6th.